to another wonderful edition of, Patio Productions, where we do pre-calc from my beautiful backyard. Today we are going to do this concept called mathematical induction. And it's a little bit of a sidestep from the lessons that we've been doing before, where we were definitely learning a lot of formulas and we were doing sequences and series, but still this idea of a series is what math induction is about. And so I really hope that you were able to download the fill-in notes for today. So it just has a cute little fill-in box. It's just going to make things a lot faster to take notes. So again, it's this guy right there. We're looking for the guy that says math induction on it. And let's go ahead and get started. So let's get this PowerPoint pulled up here super quick, you guys. And here we go. It's sunny out here on my patio. Let's get this PowerPoint pulled up. Okay, so for our math induction, ladies and gentlemen, it says we're going to do the following. So what this one really is about, it's not a lot of like math figuring. It's going to be a lot of writing, right? Like, oh my goodness, are you going to be okay with the writing? Like, I don't know. I think you're going to be able to. So, no, don't feel that way about the writing. It's going to be totally fine, okay? So for the writing for today, it's just a pattern. And I don't know if you remember back in geometry where you did these like geometric proofs where you had to like write a little bit of sentence and then a little bit of math and a little bit more sentence. It's kind of in that like vibe, right? Yeah, so there's going to be a lot of writing, but a lot of the writing, and you're going to be super, super excited about this, is the same from question to question to question. And so it's going to be like pretty smooth to get that part down. And then there's going to come this like step where then you're going to actually have to do some mathematics. And it's going to be amazing, you guys. Okay, so here's what we're going to do. We're going to try to explain what math induction is first, okay? It's going to be a little bit like clunky at the beginning, right? Just like a little bit stiff and weird until you get in there and do one, and then it's going to be so much better, okay? So what you're doing in math induction is you're combining some mathematical steps with some English statements also. Every one of these guys is like a 3-part proof, okay? And you have to have all the pieces. You have to have the English part and you have to have the mathy part. You have to have both parts. So like literally everything that shows up on the screen is the answer for one of these induction questions. And you don't have that many of them for homework, okay? So basically, they're going to start you off with a statement involving natural numbers, and we're just going to call it P sub n, okay? So your very first step is to, and like literally, you guys, let me get my little pencil guy right here. Where's my pencil guy? Pencil guy, pencil guy. Where are you? Where are you? Oh, I found you. I found you, pencil guy. Okay, this step right here, this statement right here, which you're going to be writing on your notes momentarily, is exactly what you write down on your paper as part of the answer for step number 1, right? Because we're going to have 3 steps. So step number 1, you verbatim write this. Prove that P sub 1 is true for n equals 1. Verbatim, write that exact sentence. Okay, then what you're going to do is you're going to show that it mathematically works for n. There is going to be, basically the structure is going to be a little bit something like this. You're going to have like some blah, 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 some numbers, and then you're going to have an equal sign, and then you're going to have blah, 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 some stuff. You're going to show that basically like the first thing that happens on this side is going to be the same as plugging in 1 on this side. And it's going to work lovely, and you're going to see it work, and you're going to be like, oh my goodness, that's totally good, okay? So then what you're going to do for step number 2, right? So again, you're going to write a number 2. You can either do Roman numerals or regular numbers. And you're going to literally write these words. You're going to literally write down that says, assume, okay, P sub k is true for n equals k. You write that down, okay? After you write those exact very words down, then you're going to just copy down the original statement. And instead of having an n in it, you're just going to very simply write it with a K. That's it. It's going to be so simple. No thinking on this second step, basically just like a regurgitation, okay? Like literally like, bleh, here's the step, Okay. Then for step number 3, guys, this is where all the work comes in right here on step number 3. You are going to literally write down these words, like literally write down these words. You're going to write down, prove that P sub K plus 1 is true for N equals K plus 1. And then comes the work. Yes. Okay, we're going to build from step number 2. So you're actually going to copy down whatever you did in this guy up here. You're going to copy it down, and then you're just going to build on it. When we do the first one, I'm going to walk you through how to build on it. And then remember, guys, since this is on video, you have the ability to rewind, pause, think about it, and then really make sure that you get these down, okay? I honestly think these aren't going to be like amazing until you do some of them in the homework, and then they're just going to start getting easier. Okay. I promise it will get better. I promise. Okay. So your conclusion, and you are literally going to write these words, guys. You are literally going to write this entire sentence, and it's going to say, by mathematical induction, comma, the above statement is true for all natural numbers. You literally write down that sentence. And then at the very end, and we're going to show this on the first example that we do, you actually finish it off with the letters Q, E, D, which is kind of like the equivalent of just doing kind of like an amen or mic drop, or be like, boom, that's what it is. Okay. So that's what you're going to do. And it's just the math way of saying like, yep, did what you asked me to do. I'm all finished now. Okay. Honestly, the best way to learn this, guys, is to just get in there and do some. So I have provided with us 2 examples. They're different types. Okay. So there's one type that's going to be in your textbook, and then there's going to be another type that I'm asking you to do additionally, and you're going to learn how to do both of those right now in notes. We're doing a whopping 2 examples, okay? So this is our first example, number 1. It says, use mathematical induction to prove that the sum of the first n odd positive integers is n squared. Typically, what's going to happen is they're going to give you like the math rule written out, okay? And you guys can see right here, okay, you can see that they have written out the first however many odd numbers that they wanted to. 2n minus 1 does represent any odd number. If you think about it, plug in any integer, and you're going to get an odd number. And apparently, no matter how many you take, it's going to be the number that you had squared. That's what the sum is going to be equal to, which, by the way, I think it's kind of cool that that happened, okay? So you don't have to come up with these rules. They're giving you the rule, and then they're like, go prove it. So you're like, okay, boom, let's do this, okay? Let's prove it up. So the first thing you write down, hey guys, notice what I wrote down for step number 1. I wrote down, prove that P sub 1 is true for n equals 1. Guys, I literally wrote that down for the first step. I'm writing those words down on my notes on the first line. Okay, prove that P sub 1 is true for n equals 1. Then what's going to happen is you're going to go ahead and get the first term, which is this guy right here. And then every time you see on the other side of the equal sign, whatever you see the 1, you're going to plug in, every time you see an n, sorry, I accidentally said the wrong thing. Every time you see an n, you're going to go ahead and plug in a 1, okay? So I'm going to grab the first term, which is a 1. Does that equal 1 squared? So guys, you're literally writing this down. Like, I know that 1 equals 1 squared, like obviously, but you have to prove it. You have to show your work. So you write down, does 1 equal 1 squared, question mark? And then you say, yeah, 1 squared is 1 times 1. And so 1 equals 1, check mark, ta-da. That's how it works, the end. Step 1, complete. Okay, let's go to step number 2, where I literally write down the words. I am literally writing down these words. Assume that P sub k is true for n equals k. I write these exact very words. And then very, 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 very simply, all I'm going to do is I'm going to go up. I'm going to switch colors right now, guys. All you're going to do is you're going to grab this entire statement right here, and you're just going to recopy it down. And anytime that you see an n, you're going to put a k instead, okay? Because we're letting n be k. So every time you see an n, write k. And this is what you write down. Okay, super simple. You're going to write 1 plus 3 plus 5 plus ... plus the quantity. Go ahead and leave that in parentheses. 2k minus 1, close that parentheses, equals k squared. And guess what? Step number 2 is done. That's it. That's all you have to do. Okay, let's go to step number 3. Here's where the work comes in, right? Like, here we go. Here comes the work. Okay, here it comes. So we're going to prove, oh, look at this. You are writing this exact very line, okay? You are writing down the line that says P sub K is true for, I'm sorry, P sub K plus 1 is true for N equals K plus 1. You literally write that sentence. Now, after you write that sentence, you're now going to do the work, okay? Now, the work that you are going to do is going to build from step number 2. So from step number 2, where's my little mousey guy? I lose my mouse sometimes, okay? So on this step number 2, basically you're just going to start by copying this step down. You literally copy step number 2 down, and then you're going to build on it. Okay, you are going to build and work the right-hand side. Let's get a new color again. Let's get a new color. Can't have all the same colors going on here. Let's do purple. Okay, so you are going to take this guy right here on the left-hand side, and you're going to add the next term because we want P sub K plus 1. So we're going to have to figure out what the next term is. Then what's going to happen is to be equal in mathematics, if you add something over here to one side of an equation, well, it has to be equal opportunity, like, of course. So whatever you put here on the left-hand side is going to need to be added over here to the right-hand side. Okay, so what am I adding? Well, folks, we want P to be K plus 1. So this, I'm going to literally copy this again, and then in place of the K, I'm going to put a K plus 1. Okay, so notice that everything so far, all of this right here is literally a straight copy, straight copy, straight copy, straight copy. And then there's this plus sign. And now I'm adding the next term. The next term is a 2 times K plus 1. Close that up and then minus 1. Okay, the left-hand side was a K squared. And then I'm going to, And then I'm going to go ahead and add that term. Because if you add something to the left-hand side, you have to add something to the right-hand side. So we're going to add the 2 times the quantity K plus 1, close that up, and then minus 1. Ladies and gentlemen, that is going to be gorgeous. So now what you have on your notes is a little bubble that says want, okay? This want bubble is actually just a helpful place for you to write down your thoughts on what you want this right-hand side of the equation to be. Okay, so what I want this right-hand side of the equation to be is I want it to be, where's the mouse again? Guys, I keep on losing the mouse. Okay, we want this K to now say K plus 1, okay? So in my little thought bubble, I want K plus 1 to be squared. Okay, that's what I'm going for. I want the N to be equal to K plus 1, okay? And I want that on that right-hand side, it's the quantity, whatever N is squared. So I'm saying that N is K plus 1. So I'm going to do K plus 1 squared, okay? So basically, guys, you are now done technically with this left-hand side of the equation. It's finished. You've added the next term right here, right? You added the next term. So wait. It's so sunny out here, you guys. Okay, so you're going to add the next term, and we're done. So the left-hand side is finished. Now I just need to do the right-hand side. So let's just do a little mathematics, right? Like, we can do math. Let's distribute that 2. So if I distribute the 2, I get K squared plus 2K plus 2 minus 1. I'll combine some terms and take away some parentheses. So K squared plus 2K, I combine the 2 and the negative 1, and I got 1. And then anybody want to guess, like, what K squared plus 2K plus 1 might maybe, like, factor into? Of course it is K plus 1 squared. Yes, we did it. Woo, woo, woo. Okay, so amazing. We're finished. We put a check mark by that, and we're done. We figured out what it was supposed to be. So you do your ending statement of, by mathematical induction, the above statement is true for all natural numbers, literally straight copying that sentence. And then you write QED at the end. Okay, so on the previous slide, I kind of like mentioned about this QED. So again, it's just like, boom, I'm finished. I did what you asked. And so what that actually means is it's Latin for quod erat demonstratum, which means which had to be demonstrated. So it means I did what you asked me to do, and now I'm finished and I'm done. And guess what, guys? Dun, 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 dun. We have finished one mathematical induction question. Good job, everyone. Give yourself a round of applause. Round of applause. Round of applause. Excellent work. Okay, this is one type of math induction problem, okay, where they give you the rule and then you go through the steps. Again, that step number 3 is probably the hardest. Go ahead and turn this baby over to the back side of your notes, and then we're going to do another type of example. Okay, so this one says we're going to use math induction to prove that 4n minus 1 is always divisible by 3. So if you take powers of 4, you can raise it to any integer, and you subtract 1, and that is going to be divisible by 3. Again, such an interesting rule I didn't even know existed. Okay, so we're going to go through the steps. So I'm going to go just a teensy little bit faster, but this one is like a little bit different, okay? So we're going to write step number 1, and we literally are writing the words, prove that P sub n is true for n equals 1. I literally write those words, okay? Then I'm going to go ahead and I am going to let's go back to the red color right here. I am going to take my rule right here and I'm going to plug in 1 every time I see the n, right? So I'm going to plug in 1 right there. So I'm going to take 4 to the first minus 1. That is 4 minus 1, which is 3. Hey guys, is 3 divisible by 3? I mean, yes, it totally is. You'll put a check mark by that and you're done with step number 1. Isn't that nice? Clean, beautiful, done. Okay, step number 2, we are told we're just supposed to write the exact thing, right? We're just going to write these words. Prove P sub k is true for n equals k. We write those words. Got it? And done. Then we're going to have to write this rule up here, right? This is our rule. We're going to write this rule with a k in it. Okay, so we're going to write 4 to the k minus 1 is divisible by 3. Now, here's the deal, guys. That being divisible by 3, that's not really a math equation. It's more like an actual sentence. And so I need to figure out a way to make this into an equation that demonstrates that number is divisible by 3. The best way to do this would be to write it as 4 to the k minus 1 equals 3 times t. And t is a variable that we are introducing into the equation. T is going to represent, it says, any integer. That's where it says t is in the capital Z. That's the integer set. And so we're going to say that t is any integer. And if you take 3 times 2 or 3 times 10 or 3 times 155, it doesn't matter. Those numbers will be divisible by 3. So this mathematical statement right here, okay, so right, this is our mathematical statement. This mathematical statement right here is saying what this guy said in English, okay? We are saying that 4 to the k minus 1 is a multiple of 3. Therefore, it would be divisible by 3. Step number 2, all finished, gorgeous, the end. Okay, let's try step number 3 now. We're writing the words, all the words. We're writing the words. Prove that P sub k plus 1 is true for n equals k plus 1. Okay, so we're writing that guy again. Now, how do we prove that? Okay, what did we do on the previous question? We started with step number 2. So I am literally copying it down, right? This is step number 2. I just straight copied it down. Boom, done. Okay, just like that, straight copy. 4 to the k minus 1 equals 3t. Now, I'm supposed to be getting a k plus 1 in the place of the k. So right now this has a k, and I need it to be a k plus 1. Now, unlike the previous example where it was a series and we just kind of added that next term, we're going to have to create a way for us to get a k plus 1 in this power. Okay, one way to do that is to multiply that side by a k plus 1. Okay, so we're going to do that in just a moment. Before we do that, though, we should probably look and we should figure out what we want to get. Okay, what do I want? If I'm wanting to get that n is k plus 1, I need to go over here and I need to figure out a way to get this. This is what I'm going for. I'm going for a 4 to the k plus 1 power, then minus 1, like on the lower level, is 3 times something. Really, it could be anything because 3 times, if it's like, as long as it's an integer, okay, means it's a multiple of 3. So that's what I'm going to be going for, okay? This is my end result. So like I was saying, how do you get at a k plus 1 power over here on this left-hand side? We're going to multiply it by 4. Now, here's the deal. In mathematics, kind of like the other example, If you do something to one side of the equation, of course you have to do it to the other side of the equation. We are 100% an equal opportunity organization. So if we are going to multiply by 4 on the left, we're going to multiply by 4 on the right. Now, I'm going to take the entire thing and multiply by 4, and then on the left, and then the entire thing on the right and multiply by 4. So now I get 4 parentheses, 4 to the k minus 1 equals 4 times 3t. Now, I'm going to distribute the 4 on actually both of those sides. So on the left-hand side, what I'm going to get is I am going to get a 4 to the k plus 1 minus 4. Ooh, nice, right? So pretty. Equals 12t. So guys, I feel like I'm kind of like on my way. I've gotten this k plus 1 power, and I'm like super stoked. But I really, when I go to my want bubble, I want this 4 right here to not be minus 4. No, 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 no. I want this 4 to be a 1, a minus 1. So how in the world can we make this 4 right here turn into a 1, right? So what I'm thinking is, why don't we not like add 4 to both sides, because like that's legal, but what if I just added 3 to both sides? 3, Mrs. Fox. Yeah, if I added 3 to both sides, what I would get on the left is 4 to the k plus 1 and then minus 1. And on the other side, I would just have 12t plus 3. Guys, I kind of think this is totally working out. So now the left-hand side of my equation is completely done. I'm done with this guy. He's finished. Now I just need the right-hand side to be 3 times something. So if you look at this left-hand side, what do you guys see? Do you see that maybe we could factor out a 3? Let's do that, okay? If we factor out a 3 over there on the right-hand side, I get 3 times 4t plus 1. And ladies and gentlemen, just like that, we have said that 4 to the k plus 1 power minus 1 is 3 times something, okay? Because t is an integer, 4 times an integer plus 1 is still an integer, and we have finished it. Bum, 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 bum. Easy. We are now going to go ahead and write our conclusion sentence, which says, by mathematical induction, the above statement is true for all natural numbers. You finish it off with a QED, just like that. And guys, we have now done a second math induction type, okay? And everything that you see on the screen, is the answer. In your homework, you are going to have, okay, 12, 13, 14, 15, 16, 5, 21, 28. You have 7 different ones to practice the first type that we did. And then you have 2 additional questions, okay, on the second type that we did. Just as a reminder for your laws of exponents, this is actually written on your paper, but remember that how you do exponents, we kind of like did this on our previous example, but just how to write exponents, that would be good for you guys to check out right there. So here's the thing. You may be like, Mrs. Fox, that was so crazy. My brain is literally scrambled up right now. Like, could you just maybe do like one more? So guys, yeah, let's do it. Let's do your first homework question together. Okay, so let's do page 702, number 12. Honestly, guys, I picked this one because the mathematics for step number 3 is a little bit more involved. So this will be good for us to do it together. Just one more example so that you can see it happening. And again, the meat of the problem, the meaty part of the problem is happening in step number 3. Okay, so here is homework question number 12. It says, use mathematical induction to prove, and it gives us this beautiful thing. Remember, you're not having to come up with this. This is all by itself, okay? You are just, they're giving it to you. It's an interesting thing, and you're going to prove it, okay? So it says that 1 squared, so basically if we take the sum of the squared numbers, 1 squared, 2 squared, 3 squared, up to whatever number you want to stop, it's actually the same thing as taking that number times 1 more than it, times double it plus 1, and dividing by 6, and it's the same thing. Who knew, right? This is an amazing, fun little fact. Who knew about that? I didn't know about that, but now we're going to prove it, okay? I'm going to actually take 2 slides to do this just to spread out my work, but again, the first 2 steps should be pretty easy, okay? So I'm going to actually go through these kind of fast. You can always pause the video if you want to. Okay, we're going to write down the sentence that says, prove that P sub 1 is true for n equals 1. Got it? Love it. Copied it straight down. I'm going to go ahead and I'm going to take my very first term, which is 1 squared. And then over here on the right-hand side, I'm just going to plug in 1 every time I see an n. And I'm going to show that those two things are the same thing. So 1 squared equals, so I'm taking the 1 out front, that's the n, times 1 plus 1, times 2 times 1 plus 1. This is 1. This is a 2 right here. This is 2 times 1 is 2 plus 1 is 3. So we're going to take 1 times 2 times 3, which is 6. Okay, and then we're going to divide by 6. And wouldn't you know it, 1 equals 1. Put your little check mark. Done with part 1. Let's write part 2 down. Part 2 says, assume P sub k is true for n equals k. You are verbatim writing those words, and then you're going to take the entirety of the rule, and every time you see an n, you're going to write k instead. So I have simply written down, beautiful, smooth, easy, 1 squared plus 2 squared plus 3 squared plus dot, 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 plus k squared equals the quantity k times k plus 1 times 2k plus 1, all divided by 6. Done with step number 2. Now comes the hard part, step number 3. But you guys got this, all right? Boom, let's do the hard work, right? This is where the hard work comes in. So we're going to prove that P sub k plus 1 is true for n equals k plus 1. We start by literally copying down step number 2. So I got my 1 squared plus 2 squared plus 3 squared plus dot, 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 plus k squared equals k times k plus 1 times 2k plus 1, all divided by 6. Beautiful, gorgeous, I love it. Okay, then we're going to add the next term to the left-hand side. Okay, we're going to add the next term right here to the left-hand side, and because we added it to the left-hand side, you're going to take that same term and you're going to add it to the right-hand side. Okay, now, the next term on the right-hand side would be the k plus 1 term squared. So we add k plus 1 squared on the right. We add k plus 1 squared on the left. So it's on both sides. After you've done that, it is probably the wisest decision right now to figure out what you want that right-hand side to turn into, okay? So in your want bubble, okay, you want every time you see an n from the original, you want it to say k plus 1 instead. So I believe it said n. So we write k plus 1. Times n plus 1. So we write k plus 1 plus 1. Times 2n plus 1. So we write 2 times k plus 1 plus 1. All that whole thing divided by 6. Okay, now I'm going to be super honest with you guys. There is no way that it is magically going to turn into this. Like, I'm serious. It's not even going to happen. No way. Okay? So what you're going to do is you're going to give yourself a fighting chance by doing one more step. Okay, by doing a slight combination of this, of just like combining a little bit like terms for something that it's more likely that you're going to get. And then you're able to take that and then undo it and know that it basically came from this. Okay, so I'm going to do a little bit of combining. The first term is still a k plus 1. Check. Okay, so this is still a k plus 1. This one right here, k plus 1 plus 1 is now k plus 2. This one right here would be 2k plus 2 plus 1. So this guy right here is 2k plus 3, and then it will be divided by 6. Now, this left-hand side is done. Now we're going to manipulate this right-hand side, and what's our goal, guys? Our goal is to get this. Okay, this is what we're going for right here. And then after we get that, we'll know that it came from the original, and we'll be able to write it up here. Okay, so the first thing, guys, that we like to do, if there's two things that are fractions and we want to add them, we need to have a common denominator. So I'm going to make this k plus 1 quantity squared term be 6 over 6. Okay, so I'm going to make a common denominator. And then I'm going to sort of like combine the terms. Okay, so now this whole thing is going to be over 6. And please notice something. This is very interesting. When you put these two guys on top of each other, this is going to be one term. And then this is going to be another term. There's going to be two terms on the top of your fraction. Now let's look a little bit closely at these two terms. Do you guys see that they have one thing in common? And when you have something in common, we call that a greatest common factor. You can factor that out. Okay. I see that both of these have a k plus 1 right here. And then this one has two k plus 1s. So it's definitely, they have one of these in common. So on the next line, what I'm going to do is I'm going to take out one of the k plus 1s. What's left from the first term is a k and a 2k plus 1. What's left on the second guy, the second term, is a 6 and a k plus 1. And then everything's all over 6. Okay. Now, if I'm looking at what my goal is, folks, look at this right here. I've already got the k plus 1. What I need to now figure out is if what's left over can factor into a k plus 2 times a k, 2k plus 3. And P.S., it totally does. So let's go ahead and expand this guy over here. We're going to expand this guy, and then we're going to refactor it so that it turns into a k plus 2 times a 2k plus 3. So the k plus 1 stays the same on the outside. I would make this be 2k squared plus k plus 6k plus 6. And then it turns into, after I combine like terms, a 2k squared plus 7k plus 6. Hey, guys, I know what it's supposed to factor into be. Don't do any of the work. Like, I'm not kidding, okay? We're not trying to be like super mean and be like, oh, you have to try to factor this. No. It's going to be so easy. Just, you know what it's going to factor it into be, okay? You're just going to go like this. Boom. Done. I'm finished, okay? So you're just going to factor it knowing that that's what it factors into already. A k plus 1, which was on the outside, a k plus 2, and a 2k plus 3. And then you have to write one more step. One more step, Mrs. Fox, I thought you said we were done. No. You have to write it so that every time you see the K, it changed into a K plus 1. And so we write this. Okay. But you knew that this was going to happen. That's what you wrote down in your WOMP bubble at the very beginning, where you were replacing every time you saw an N with a K plus 1. You put your check mark, you write your conclusion sentence with your QED that says, by mathematical induction, the above statement is true for all natural numbers, and your QED, and you're finished, just like that. That was a lot of work, you guys. That was definitely not easy. Okay, so let me get back to my screen, and let's talk about some of the things, okay, that I've posted to Google Classroom for our benefit, okay? So just a quick little check-in. Folks, on Google Classroom, what I've posted is the fill-in notes, but then I also posted actually answers, because these math induction ones are not easy, and I don't want you to struggle and feel sad, okay? So I want you to use them responsibly. Please make sure you're trying these by yourself. But what I've done, I didn't write out the whole proof, because honestly, step 1 and step 2 and the conclusion are super simple. I basically just did step 3 for all of the homework questions, because I wanted you to be able to check your work, okay? So please use it as a benefit. I think you guys will you're going to do a great job. It's going to be clunky at first. It really is. It's going to be like a struggle, but then you're going to get in there and you're going to start doing them, and then it's just going to become so much easier. It'll be smooth, I promise. Okay, let's send it out with our music, and I hope you guys have a good time doing this lesson. So until our next patio production time, bye guys. See you later. Adios.